All right, well, welcome. I'm Terrell. I work on iRODS. Have you heard of iRODS before? Okay, we'll go easy. All right, we're a CMake project.
That's good.
All right.
I know that. I developed that.
We're starting off strong. All right. So I work on a piece of open source software called iRODS. It's a C++ client-server application. It's BSD3. It's wide open. We have people all over the world that have been using it for many, many years to keep track of all their data and manage the things that are important to their enterprise. The sustainability model around the piece of software is a consortium. So the idea is that people use it, they take care of all their stuff, they don't want the software to atrophy, and so they join the consortium to make sure that the software stays around for a long, long time. The consortium itself is not actually a real entity. We exist under the Renaissance Computing Institute, which is one of 60 or 70 research institutes at UNC in Chapel Hill, North Carolina. So I'm a state employee, and we all work for the university. There's no company here. It's a consortium play as a research institute. This slide changes every few weeks, but we've up to 25 people now, 25 organizations, 2 of which are suspiciously anonymous. They have not given us rights yet to put the logo on the slide, but our membership largely consists of people doing science, people trying to sell them storage, and the integrators who are boots on the ground. We're not a very large organization, so we don't really do the on-site support after somebody deploys this stuff. So we provide the software and the training and the support to get off the ground, and then the idea is that people run it themselves and manage their own infrastructure. So if we do our job well, nobody really knows that we're doing anything. We're right in the middle, kind of invisible. We sit above whatever it is that you already have. That could be in terms of storage, compute, authentication, indexing frameworks, whatever you've already got running. We're kind of the glue between that, and we abstract all of the stuff and provide an API and client libraries and applications that talk to the iRODS layer. This allows us to abstract all the types of storage, types of compute, into a consistent thing that is future-proof as you maybe buy other companies or migrate your data, buy a new filer, and have to move your stuff around. So it gives you that continuation into the future. So for a few years now, we've been explaining what we do. We say we do 4 things well. We abstract the storage, so we provide a logical namespace. We present as a virtual file system, effectively. We provide a metadata catalog where we write everything down about stuff. That's stuff from the system as well as stuff from the users. And then we have a policy engine on top where you can write code, or we can help you write code. You can deploy and configure existing code to take action on your data based on the metadata. So we talk about metadata being prescriptive in addition to being descriptive. So you can write down where you are in the pipelines, where you'd like it to go, who's working on this, what stage they're at, and then move the stuff around as you need to. Because it's an open format and an open protocol, it can actually federate with other instances of iRODS. So if another organization, a partner organization, is running iRODS as well, it's very granular permissions you can set, change. If you go over the federation and go into their house, their policies are in force. If you allow somebody into your space, your policies are in force. And that includes auditing and all kinds of stuff. So that was, if you look back, so this graphic in the top left, we've solidified around explaining it this way. So we kind of moved from the bottom of the kind of core competencies up to the top level. So above the kind of how the software exists, with the rule engine, we can write different policies that cover many, many different scenarios. So we have this conversation with people all over the world for the last few years, and we try to, the goal is to boil down the landscape that we see, the use cases that we hear about, and write open policies that we share and incorporate into the technology. So if you need to do this kind of stuff, you can do it with the rule engine. You don't have to write this code anymore. We've already done these things. How you stitch them together is up to you. So moving up the stack a little bit more, you can build certain capabilities with those policies, and we now have downloadable code that you just have to configure in order to do things that are usually very complicated and expensive, like all of your storage tiering needs across a variety of flavors of storage, including maybe some of the stuff from SUSE. We've got auditing, automated ingest. If you need to make claims about compliance, we can help you do that, because with confidence in how the system works, and if it's automated, you can make very strong claims about how the data got to the state that it's in, including the other things here. So as one example, for this particular talk, for this particular booth, this is one of those one-pagers about those capabilities for storage tiering. It doesn't have to be 3 tiers. It can be driven by your metadata. So you can have as many tiers as you want. You can go out from disk to object to tape to cloud. It doesn't matter to us. It's all abstracted. And you're just providing replicas in the logical namespace. So, having talked to many people and seen this for a few years now, there are 4 patterns that we've identified. There's probably a few more to come, but these things take time to kind of solidify. The first one that we found was the data to compute. So for this audience, most people here have a big orange computer somewhere sitting in a basement, right? And when you want to do your science, you move the data to the big computer, you run the science, you get the results. And so in our world, that's just another replica and a trim, and then you register the results, and it's all part of the same flow. Or you can flip it on its head, because the data is too big to move, or too heavy, or too expensive. You can move the data, you can move the compute jobs to the data in place, because the data has already been routed to the right place because of its automated nature of being ingested and tagged well. Keeping things in sync in 2 directions is tricky. We can do it with a policy engine, and this most recent one is data transfer nodes. A lot of organizations now need to share and work with other academic institutions or commercial institutions. And so you've got your in-house data flows, your long-term storage, your tape archives, but as soon as you want to work with somebody else, you need to put them kind of in some kind of DMZ or ingress and egress situation. And so again, we can do that with ease with the policy layer. So all that to say, almost all the use cases we've heard the last few years are some subset of this picture. So these are the 8 things, and whatever your use case is, we feel like you're here. If you come up with a 9th circle, we'd love to talk to you, but for the most part, everything we've heard about fits in this category. And here are the patterns. We haven't updated this one yet to have the 4th. The other nice thing about this is that if you don't need all 8 yet, nobody really does yet. Most people show up for the tiering and the ingest because they have existing infrastructure. They want to get into a system where they can index it and see it and search it, and then they want to move it around cleanly. Later, if you ever want to add this other stuff, it's not hard. The framework's already there and can support it. So all that said, so SUSE is a relatively new consortium member, and we wanted to run some tests on the SUSE Enterprise Storage, and we were provided some VMs into SUSE Network. We installed iRODS and did some performance testing, and it turns out that the CephFS is very, very quick. It was actually faster than the local disk, which does make sense when you step back and think about it a little bit. Through just the local mount point, these are all in seconds, by the way. Going through iRODS, this was a run of, I think, 5 or 10, so this is an average. So for some reason, it was actually faster going through iRODS layer than it was on the local. That's a little suspect. I'm still looking into that. But these are dramatically faster than going through the local disk. And then we also went to the S3 interface for the enterprise storage. And so that's an abstraction in two directions. So going through the S3 interface with the Minio client, it was about the same as what we got up here. But our S3 plugin is not quite optimized yet to handle large files moving up and down. It does work fine, but there's a penalty hit because we have to write it down because we're going from the POSIX interface into the object interface, and so you can't do a partial put into an object store. So some work to be done here, but for an initial test run, we were pretty pleased with ourselves and with all the work that SUSE has done. We actually have a plugin that talked to librados earlier, before CephFS was a thing at all. And so CephFS has done a lot of work to optimize this, and so we're pretty pleased with the arrangement so far. That's all I have for this talk. We are over in booth 781. We've solved lots of problems. We'd love to hear what yours are, and we can probably help you with them. Ask me a question.
From an API standpoint, do you also have an API object interface, or is it only the file system interface?
Whether iRODS presents as S3?
Yeah. Not just S3 or not, just an object interface.
I see.
Or is
So
it only the file system?
we have a client, not a customer, a computer client program that has presented the iRODS interface as it, but now you're going through multiple layers. So it's not going to be performant, but it does allow people to, if they have existing infrastructure that speaks object, they can put us there. We have many client libraries in different languages. Lots of people have built GUIs, we've got command line stuff. So yes. Yeah.
Say anything more about your metadata catalog, whether it's public,
Right. So the question's about the metadata catalog. We use a relational database. We are agnostic as to whether it's MariaDB or Postgres or Oracle. So it's a plug-in model, so we can go to anything. We actually have one for Cockroach database as well. And then so what we put in it is stuff to keep track of where the things are, but also every user of the system, it's multi-tenant, multi-user, they can put arbitrary user metadata on things as well. And so any of that metadata can be queried to drive the policy. So if you're doing science, you can do a query across any number of things, operate on the result set as a cohort for, run 52 of your experiment or whatever it is. Happy to talk more. Anybody else?
Any other questions, guys?
All right.
Let's give her a
Thanks.
applause.